Mr. Otabek.
Good morning.
Mr. Abos and Mr. Amir.
Mr. Abbas and Mr. Amir.
Okay, Amir. Don't take that one. Okay, so our lesson for, are we ready?
Yes.
Okay. Okay, today our lesson is about DC motor. Okay, so what is DC? Direct current. Okay, this is found on page number 384 of your book. You can go to page number 384 of your book. So I have here a my very special mag, by which I will call, I have numbered you from 1 to 12, and then when I pick a number here, so it's your turn to shine. It's your turn to answer our question. Okay? So let's start first with our objective for today. Okay, number 8. Alisher, can you read our objective for today?
Creates a magnetic path within the stator. Magnets.
I mean the learning objective. Can you read our learning objective? State
States that a current carrying coil in a magnetic path experiences a turning effect, and that the effect is increased by increasing the number of turns in the coil, increasing the current, and increasing the strength of the magnetic path.
Okay, thank you, Alisher. Okay, so before we start our lesson, let's have an extra challenge to answer this crossword puzzle. Mr. Otabek, would you write to get and pick who will answer?
Unike. Afroza.
Can you come on the front, Afruza? Read to us the question. By the way, this is a crossword puzzle. There are questions and clue down and across, and then you write your answer on the board. Afruza?
Electrical machine that converts electrical energy into mechanical energy.
I mean number one.
Number 1.
Yes.
Creates a magnetic field within the stator.
Okay, and the answer is?
Magnets.
Alright, correct. Magnets. Can you write that one? Okay, next, number 2.
Tokas.
Dinara. Read to us the clue first and you write the answer on the board.
Electrical machine that converts electrical energy into mechanical energy. Motor?
Yes, it's a motor, correct. Motor. Right, great. Thank you, Dinara. Next.
Yitte.
7.
Timurvik.
Timor.
Conduct electricity to the individual segments as they rotate from brush to brush.
The answer is?
Brushes.
Brushes, correct. Right. Thank you, Timor. Next.
Next. 2.
2.
Assures that the current from the generator always flows in one direction. Commutator.
Yes, commutator, correct. Alright. So our puzzle now is taking shape. Last question.
Oxirgisi 4.
To increase the turning effect of the coil in the motor, we increase the current.
Correct, current. Okay, thank you for your participation. So that's very good for answering correctly our crossword puzzle. Okay, now let's go to study about this DC motor. So this is a DC motor. It's a piece of equipment that converts electrical energy into mechanical energy. Okay, so on the first picture is what we will see if we will open something like a toy, which contains a DC motor, but that one has a casing. If we will open it inside, we will see that the DC motor contains something inside which has coil of wires. And how many coils of wire do you see? Is it many? Yes, it's many. Later we will understand why the many wires of coil will increase the rotation of our motor. Okay. Now at this time, let's take a look first how our direct current motor works. So as you can see, we have there the coil and we have north-south of the magnet. Okay. So on letter A, there are two forces that are coming from our current by which it is moving on the longer side of our field, which is side AB and side CD. Is there a force on side CB and DA? Is there a force there?
Yes.
Yes.
There is a force, but only from the magnetic field. But the current is not flowing at the center of it, right? Because we have a magnetic field. Okay. On letter B here, as you can see, we have a force upward and we have a force downward. And because of that, it will create a torque. Yes, a torque. Or a couple of force. A couple of force. So, a couple of force are two forces that are in opposite direction and they are in distance by which there is a perpendicular distance between the two of them. And because of that, it creates a turning effect. Okay, there is a turning effect on letter B. Now, is there a turning effect on letter C? No. Why no? Number 11 is Oisha. Number 11. Why is there's no turning effect on C?
Because there is no turning effect.
Because there's no? Okay, or there's no torque. And our forces here are vertical. There is no perpendicular distance. Remember, turning effect is equal to force times a perpendicular distance. Okay. So that's why there's no turning effect there. Okay. Now, our main objective for today is for you to build your own electric motor. Now, this one, I have made this one from my room in the dormitory. And let's see this one. As you can see, my motor is only made of some materials that we can see in the school, like battery, some copper wires, and some paper clips. Okay, let's watch it. Okay, did the motor works? Yes. So this is also the one that you will be making, an electric motor. Okay, as you can see, the motor is converting the electric energy from the battery into a mechanical energy, which is a form of kinetic energy. Okay, so now we build your own DIY electric motor. So I will divide you into groups. So here you will be group 1, group 2, 3, 4, 5, and 6. So each one of you will be given battery. Each group will be given a battery. Can you give this one at the back? Also, you will be given 2 paper clips. Do not waste our paper clips because this is a precious mineral from the earth. Also, you will be given a 1 meter length of a wire. What will you do with the wire? What will you do with the wire?
Use it as a coil.
Yes, you will use the wire as a coil. Okay. So everybody has an equal amount of wire. Is it enough already? 6? Okay. So do you think the more we coil the wire, it will increase the turning effect? Let's see in your wire. Okay. Now, aside from that, you will also be given, what is this? This is an, I don't know what is this in Uzbek, but in English, this is called an abrasive paper. Okay? Now, our wire contains some resistivity. It contains some resistivity. And what you need to do is to remove that resistivity by this adhesive or abrasive paper. Remove it, okay? So you will be given equally because you are an equal brother and sister. Okay. What else do you need? You tell me. If you want scissor, there's scissor here. Now I also have here an electrical tape. If you need an electrical tape, you tell me. And of course, magnet. Okay. Wow, very nice, Akbar.
Asli din.
Asli din. Asli din, Akbar.
Yeah.
Asli din. Dinara, what are you doing? You will only use the abrasive paper at the end, okay?
Okay.
Don't remove all the abrasive paper or the resistivity because it will heat up and then it will consume all the EMF of the battery. You may use your pen to coil. Scotch. Electrical scotch.
kerakmasdan sizga.
This one, Timur. I don't know if there's still some,
Saying that it's enough.
but this one is much better.
I will try this after.
Okay.
Bo'lmayapti qattiq. Katta bo'laman, kuchayib boshlaydi. Qismi ishdan tushib ketmasa bo'ldi.
Bitta narsada aylantir.
Are you ready?
Almost.
I think your wire is still very long. Okay. Well, anyway, if it's that's what you want, it's okay. Just remove the resistivity, yes.
Nima og'irlashib ketadi. O'ram ko'p bo'lgan yaxshi-da.
Okay, let's see who will be the first one to make an electric motor. Did you measure the length here? Let me see. I think it's not enough. Let's see. I think it will not work because there's still resistivity on your wire.
We need a magnet.
Magnet there. Are you ready? I think your wire is not yet fully. Yeah, just put the magnet there. Okay. Remove the resistivity of the wire.
Nasarim to'g'rilaylar. Sizni muvozanatini. Qaraylar, aylanmayman muvozanatini. Tekis qilaylik sizni o'zini muvozanat aylanib qoladi. Magnet.
I think that we have finished. It's time to check.
Okay. It's very strong.
Simlari qarang.
There, it's rotating.
Tepasi to'g'ri. Ketpay ko'tarishni katta kuch ketadi. Tutti italiani.
There.
Muvozanat yaxshimi?
There. Okay. So it's much faster when we have two magnets. So that means if we increase the magnetic field by increasing the magnets, so we will experience more rotation.
Mana bu joy tekisda aylanadigan joy.
What you need to do is to coil this one here. Coil it here so that it will be fixed. Okay, so based from your experiment, let's answer the following questions. Okay, question number 1 is for number 5, Charos. Can you read our question number 1?
List 2 ways to increase the force and current carrying conductor in a magnetic field.
Okay.
To increase the magnetic field, we should firstly increase the current, then we should increase the magnetic field, and then we should increase the number of coils in the wire.
Alright, wonderful. That's very good. So we increase the current in the coil, meaning we increase the number of battery. Then we increase the strength of the magnetic field by adding more magnets. And then we add more coils on our turn, on the wire. Next, number 2 is number 6. Aslidin, can you please read first the diagram? Read first, Aslidin, the question.
The coil consists of 3 turns of wire. The magnetic field strength of the magnet is M. With a current of 2 ampere in the coil experiences a turning effect. The first row of the table shows this data.
So the first row is that we have number of turns is 3. Our current is 2 amperes and the magnetic field is M. and our turning effect is T. So what will happen if we increase the current in the coil by 8? So what will be the answer? Yes. Will it be T over 4?
No.
Can you change your answer, Aslidin? Okay, why will it become 4T? Can you tell us, Aslidin? The turn is still the same. What changes? Mhm. 40. Okay, so we increase the what? We increase the
Current
by times.
by times.
Yes, by times 4. So our turning will also be increased by 4 folds or 4 times. Thank you. Can you click X? Thank you.